So we're going to be going through the features of y equals ln x. Now remember that ln x is the same as log base e x, the same thing. Okay, so if we go to the graph now, so this is a graph of y equals ln x. And there's a few things that you need to be familiar with. The domain for this graph is x greater than 0. So anything greater than 0 is the domain. And there's also a vertical asymptote at the point where x equals 0. So remember, the asymptote is the point that the graph approaches but never actually gets to. So x is equal to 0 for that one. And the graph also passes through the point 1, 0 because ln 1 equals 0. So let's find that point, 1, 0. So it'll always pass through that point there. Okay. And obviously the function is increasing for all x values that are greater than 0, but it's increasing at a decreasing rate. So you can see at the start here, it's increasing very quickly. Then it starts to flatten out a little bit. And then if we zoom out even more, it flattens out even more. So that y value doesn't change as much as it does over here. Okay, now we'll graph the function of y equals ex, and we'll see how those two kind of relate to each other, because they're actually the inverse of each other. So if we do this function here, y equals e to the x. So that's the function of y equals e to the x there. Okay, now the natural logarithm function is the inverse of the exponential function. So these two functions are inverse of each other. Now that actually means, so if I go over here, that means that ln ex is equal to x also means that e ln x is equal to x. So graphically, the two functions are reflections of each other in the line y equals x. So if I do another graph here, and we go y is equal to x, so they're reflected along that axis there. So to summarize, the graph of y equals ln x, this red line here, has a vertical asymptote at x equals 0 and passes through the point 1, 0. And it's the inverse of y equals e to the x. Okay, all right.